This is part 2 in our exploration of graphing square root functions. And in part 2, we're going to take a look at transformations of the square root function. The first example is a reflection of the square root function over the x-axis. Notice we have a negative in front of the square root symbol. And that means that every time we take the square root of a number, for example, if x is 4, the square root of x is 2, we're then going to make it negative. So what I'm going to do before I answer these questions is I'm going to graph the square root function, the parent square root function. And you'll see I plotted the points 0, 0, because the square root of 0 is 0. The square root of 1 is 1, and the square root of 4 is 2, and the square root of 9 is 3. So what you see graphed in pencil is my parent square root function. And then I reflected those points over the x-axis. The square root of 1 is 1, but then I made it negative. The square root of 4 is 2, but then I have to make it negative. The square root of 9 is 3, and then I make that 3 negative. So what we see is graphed right here in green, and you see that the square root function has been reflected over the x-axis. So let's answer questions about domain, range, and intercepts. We can see that the domain of this function is again x values that are greater than or equal to 0. We can't take the square root of a negative number and get a real number. Our range, however, is values of y that are less than or equal to 0. If you look at the graph, you'll notice that all of my y values are negative, and then I would also include 0. My y-intercept is again 0, 0, and my x-intercept is at 0, 0. So that is the graph of the square root function reflected over the x-axis.